Hello. Today I'm going to discuss about electricity and magnetism. It is the 11th chapter of Grade 10 Science. This matter is equally important for all SE appearing students. So let us start the lesson today. It's carried the marks 6 plus minus 2. Learning outcomes of these chapters are: after the completion of this unit, students will be able to introduce direct current and alternating current, demonstrate and sketch the diagram of magnetic field formed around state conductor and solenoid with electric current in them, introduce magnetic lines of force and magnetic flux, introduce motor effect and describe its uses in daily life, mention Faraday's laws of electromagnetic induction and explain the working process of dynamo and generator based on it, study structure, working and importance of transformer, and solve the simple numerical problem related to it. The current, alternating current, the current whose polarity, we can write whose polarity changes periodically with time is called alternating current. For example, current produced by AC generator and dynamo, etc. Direct current, the current whose polarity does not change periodically with time is called direct current. For example, current produced by dry cell, photocell, battery, etc. Current time graph, the graph obtained by plotting current versus time is known as current time graph. Magnetic effect of current. Magnetism can be produced from the electricity, and this effect is known as magnetic effect of current. Danish scientist Hans Christian Ørsted discovered this effect. Magnetic field. Magnetic field is the region around a magnet up to where its influence can be felt. Magnetic field around a straight conductor. If current is passing in a straight conductor, then the circular magnetic field is produced around it. If the current is passing through a straight conductor in upward direction, then the circular magnetic field will be produced in anti-clockwise direction. If the current is passing through a straight conductor in downward, upward opposite is downward direction, the circular magnetic field will be produced in clockwise direction. This figure is shown later. Maxwell right hand thumb rule. According to this rule, if the thumb of right hand represents the direction of current in a straight conductor, then the call of the remaining finger represents the direction of magnetic field produced. Solenoid is a cylindrical coil of insulated wire that can be wound on iron piece to make electromagnet. In other words, solenoid is the helical winding of insulated wire used to make electromagnet. Magnetic field around a solenoid. Magnetic field around a solenoid is like that of bar magnet, such that one end of the solenoid acts as north pole and other end of the solenoid acts as south pole. There is uniform magnetic field inside the solenoid. The field lines inside solenoid are in the form of parallel straight lines. Maxwell's right hand grip rule. The direction of magnetic field produced around a solenoid is given by Maxwell's right hand grip rule. According to this rule, if a solenoid is gripped by the right hand in such a way that the call of the four fingers are in the direction of the current flowing in the solenoid, then the thumb will point to the north pole of the magnetic field produced. Factor affecting the strength of magnetic field around the solenoid. The strength of magnetic field around the solenoid depends on the following factor: magnitude of the current in the solenoid, numbers of turns in the coil of the solenoid, nature of material placed in the solenoid. Magnetic lines of the force. Magnetic lines of force are the imaginary lines directing from north pole to the south pole of the magnet externally. Magnetic flux. Magnetic flux is the total number of magnetic lines of force passing through a surface within the magnetic field. Its SI unit is Weber. Magnetic flux density. Magnetic flux density is the total number of magnetic lines of force passing through a unit area. Motor effect. When a current carrying conductor is placed in a magnetic field, it shows a movement, and this effect is known as motor effect. Electric motor. Electric motor is a device that converts electrical energy into mechanical energy. Electromagnetic induction. The production of electricity from magnetism by the relative motion between the conductor and the magnet is called electromagnetic induction. This phenomenon is first discovered by Michael Faraday. So Michael Faraday is also known as father of electricity. Michael Faraday's laws of electromagnetic induction. First law, whenever magnetic flux linked with the coil changes, an EMF is induced in the coil. Second law, the induced EMF lasts as long as the change in magnetic flux continues in the coil. Third, the magnitude of induced EMF is directly proportional to the rate of change of magnetic flux in the coil. Dynamo and generator. Dynamo and generator are the devices which convert mechanical energy into electrical energy according to law of electromagnetic induction. A generator produces current on a large scale, whereas a dynamo produces current on a small scale. Bicycle dynamo. Bicycle dynamo, it is a device that converts mechanical energy into electrical energy according to law of electromagnetic induction. It produces current on a small scale. Large scale electricity sources. Generator is used to produce large amount of electricity using law of electromagnetic induction in a hydropower station, windmill station, a nuclear power plant, tidal power plant, etc. AC generator is a device that converts mechanical energy into electrical energy according to law of electromagnetic induction. It produces current on a large scale. Actually, it produces alternating current. Transformer. It is a device that changes the voltage of alternating current. There are two types of transformer, namely step-up transformer and step-down transformer. Step-up transformer. The transformer which increases the voltage of alternating current is called step-up transformer. Step-down transformer. The transformer which decreases the voltage of alternating current is called step-down transformer. Working formula of transformer: Bs by Bp equal to Ns by Np, where Bs is secondary voltage, Ns number of turns in secondary coil, Bp primary voltage, Np number of turns in primary coil. Multiple choice question number 1. Choose the best alternative for the following question. Which of the following is the source of direct current? Obviously its answer is solar panel. Which of the following is the source of AC? Obviously its answer is dynamo. Who is known as father of electricity? Answer is Michael Faraday. Who discovered magnetic effect of current? Hans Christian Ørsted. Out of two sources of electricity, dynamo and diesel, which of the following statement is true? Here are a number of options, and the correct option is brightness of light lamp fluctuates if the current produced by dynamo is used, because dynamo produces AC. So due to AC, its polarity changes. That's why it fluctuates brightness. The process of production of electricity from magnetism is called electromagnetic induction. The working of transformer is based on mutual induction. Mutual induction means the phenomenon of production of electricity from magnetism and then magnetism from electricity turn by turn. The magnitude of induced EMF depends upon obviously rate of change of magnetic flux linked with the coil. The device which increases the voltage of alternating current is called step-up transformer. The device which convert electrical energy and mechanical energy is called Electric motor. The device which converts mechanical energy into electricity on large scale is called generator. To charge a laptop 20 volt, a charge with 550 primary turns is connected to AC source of this. What is the number of secondary winding of this? We can get by using formula Vs by V equal to Ns by Np, or we can directly say this and this is, we can check it here, secondary voltage, primary voltage. So how much time this 11 times less. Secondary is 11 times less than primary, then secondary here also it should be 11 times less than primary. So if we divide this by 11, it comes 50. In which of the following power stations are fossil fuel used? Obviously thermal power station. Right and thumb rule is used to determine the magnetic field of straight conductor. Magnetic field around a straight conductor. Which rule is used to determine direction of magnetic field around a solenoid? Obviously it's answer right hand grip rule. Maxwell right hand grip rule. What is the frequency of AC distributed in Nepal? 50 Hz is correct answer. Which of the following statements show the main difference between alternating and direct current? Polarity of AC changes and polarity does not change with time. This is the correct answer. State the following diagrams and choose the correct statement. P electric motor, Q generator. So correct answer. P convert electrical energy into mechanical energy. This mechanical energy. P. Q convert mechanically into light. This is not wrong. Other not wrong. What is the frequency of direct current? Obviously 0 Hertz. Which of the following is good for making core of transformer? Soft iron. Soft iron is used. Electromagnet is used in generator. That's the correct answer. An electric motor converts electrical energy into mechanical energy. Section B. What is alternating current? Section B is carrying 1 marks. Is carrying 1 marks. Alternating current. The current whose polarity changes periodically with time is called alternating current. Write in two sources of alternating current, dynamo and AC generator. What is direct current? The current whose polarity does not change periodically with time is called direct current. Mention in two sources of direct current. Its answer is dry cell and potential. State the difference between AC and DC. The main difference between AC and DC is that polarity of AC changes periodically with time, but that of DC doesn't change. What is the frequency of AC distributed in Nepal? Its answer 50 Hz. Frequency of AC distributed in Nepal is 50 Hz. What does it mean? It means polarity of AC changes 50 times per second. The graph obtained by plotting current versus time is known as current time graph. What does current time graph of DC shows? It shows polarity of DC doesn't change with time. That is, DC is constant over time. What is the frequency of direct current? It's 0. Name two devices that run with AC. The devices that run with AC are fans and electric motor. Name two devices that where DC is used. Two devices where DC is used are torchlight and internal circuit of computer. Name two devices that operate both with AC and DC. Two devices that can be operated with both AC and DC are filament lamp and electric heaters. What is used to convert AC into DC? Obviously rectifier is used to convert AC into DC. What is rectifier? Rectifier is an rectifier that convert alternating current into direct current. What do you mean by magnetic effect of current? Magnetism can be produced from electricity, and this effect is a magnetic effect of current. What are the name of scientists who first found the magnetic field around a current carrying conductor? Danish scientist Hans Christian Ørsted first discovered this effect. What is magnetic field? Magnetic field is a region around a magnet up to where its influence can be felt. What is the pattern of magnetic field around magnet produced by a current in a straight conductor? Obviously, it is circular. What is the direction of magnetic field if the current is flowing upward in the straight conductor? If the current is flowing upward in the straight conductor, the direction of magnetic field is anti-clockwise. What is the direction of magnetic field if the current is flowing downward in the straight conductor? Direction of magnetic field is clockwise. What rule describes the direction of magnetic field produced by current in a straight conductor? Obviously, Maxwell's right and thumb rule describe this effect. Maxwell's right and thumb rule. Maxwell's right and thumb rule states that if the thumb of right hand represents the direction of current in a straight conductor, then call of the remaining fingers represents the direction of magnetic field produced. What is solenoid? Solenoid is cylindrical coil of insulated wire that can be wound on irons to make electromagnet. How is solenoid made? Solenoid is made by wrapping insulated wire around a cylindrical object like soft iron. What is the nature of magnetic field around a solenoid? The magnetic field around a solenoid is like a magnetic field of a bar magnet, such that one end of the solenoid acts as north pole and another end acts as south pole. What is the nature of magnetic field inside a solenoid? There is a uniform magnetic field inside a solenoid. The field lines inside the solenoid are in the form of parallel straight lines. Which rule is used to find the direction of magnetic field around a solenoid? Obviously, Maxwell right hand grip rule is used to find direction of magnetic field around a solenoid. State Maxwell right hand grip rule. Maxwell right hand grip rule states that if a solenoid is gripped by right hand in such a way that the call of four fingers indicate the direction of current through the solenoid, then the thumb points to the north pole of the magnetic field developed in the solenoid. What are the magnetic lines of force? Magnetic lines of force are the imaginary lines directed from north pole to south pole of the magnetic external. Define magnetic flux. Magnetic flux is total of magnetic lines of surface shell perpendicular to the direction of magnetic field. What is magnetic flux density? Magnetic flux density total magnetic lines of passing through a unit surface area. What is the symbol and SI unit of magnetic flux? Symbol is phi and Weber. SI unit is Weber. What is motor effect? When a current and conductor is placed in a magnetic field, it shows a movement, and this is known as motor effect. What is electric motor? It is a device that converts electric energy to mechanical energy. Name to device where electric motor is used. Two devices where electric motor is used are fan and water pump. What is electromagnet? The magnet formed by passing electricity is called electromagnet. Define electromagnetic induction. The production of electricity from magnetism by relative motion between the conductor and the magnet is called electromagnetism. Who discovered the phenomenon of electromagnetic induction? Obviously, Michael Faraday. Who is known as father of electricity? Michael Faraday. What is induced current? The current induced in a conductor by moving it in a magnetic field is called induced current. Define induced EMF. The electromagnetic force produced in a conductor by moving it in a magnetic field is called induced EMF. What is the relation between magnitude of induced EMF and the rate of change of magnetic flux linked with the coil? Magnitude of induced EMF is directly proportional to rate of change of magnetic flux linked with the coil. Which rule gives the direction of induced current? Fleming's right hand rule gives the direction of induced current. State Fleming's right hand rule. Fleming's right hand states that if the thumb, forefinger and middle finger of the right hand are made mutually perpendicular so that thumb points to the direction of motion of conductor, forefinger points to the direction of magnetic field, then the middle finger will show the direction of induced current. What is dynamo? Dynamo is a device that can mechanical and electrical according to law of electromagnetic induction in small scale. What is generator? Generator is a device which can mechanical and electrical according to law on a large scale. What are different types of generator? AC generator and DC generator. Define hydroelectricity. Electricity produced by a rotating turbine by the energy of running water is known as What is hydropower station? Hydropower station is a house where hydroelectricity is produced by rotating turbine by energy of running water. What is meant by thermal power plant? A thermal power plant is a house where heat energy is converted into electric energy by the rotating turbine by hot steam. What is nuclear power plant? It is a thermal power plant in which heat obtained from nuclear reaction is used to generate steam from water that rotates the turbine to produce electricity. What is windmill or wind power station? Windmill is a power station in which kinetic energy of moving air is used to rotate turbine to produce electricity. What is transformer? Transformer is a device that changes the voltage of alternating current. What are different types of transformer? Transformer, step up transformer, step down transformer. Define step up transformer. Step transformer is increase voltage of alternating current is called step up transformer. What is the function of step up transformer? The function of step up transformer is to increase the voltage of alternating current. What is meant by step down transformer? Step down transformer. The transformer which decreases the voltage of alternating current is called step down transformer. What is the function of step down transformer? The function of step down transformer is to decrease AC voltage. Name two devices where transformer is used. Two devices: mobile charger and laptop charger. Step down transformer. Where is step up transformer? Is to transfer using industrial hydropower station. What is working formula of transformer? Working formula of transformer is Vs by Vp equal to Ns by Np. Name principle on transformer is based on mutual induction. What is primary coil of transformer? The coil in which input alternating current is given is called input primary coil. What is secondary coil of transformer? The coil from which output alternating current is drawn out is called secondary coil of the transformer. What is mutual induction? When AC is passed in primary coil of the transformer, it produces changing magnetic field in the coil, which in turn produces induced EMF in the secondary coil. This process is known as mutual induction. Which effect is shown in the diagram? Motor effect is shown in the diagram. Because when current carrying conductor is placed in magnet, it shows a movement. So it is a motor effect. Now, section B. Section C. Short questions is carrying 2 marks. Why don't we see change in brightness of bulb although magnitude of AC is continuously changing with time? It is because magnitude of AC changes so rapidly that our eyes cannot detect it and the bulbs appears to be glowing continuously. What are the factors affecting strength of magnetic field developed around a solenoid? The factors are magnitude of current in a solenoid, number of turns in the coil of the solenoid, nature of material placed inside the solenoid. What are the properties of magnetic lines of force? The properties of magnetic lines of force are they are close curve originating from north pole and ending at south pole of the magnet. They never intersect each other. They all have equal strength. How does electric motor rotate? Electric motor consists of coil placed between two opposite poles of magnet. When current is passed through the coil, a magnetic field is developed around it. Due to the interaction between magnetic field developed in the coil and magnetic fields of the permanent magnet, the coil starts to rotate, which rotate the other object attached to it. How is electricity produced in thermal power plant? In thermal power plant, heat produced by burning of fossil fuel like coal, diesel, etc. is used to heat the water and generate steam. This steam is made to move in high speed to rotate the turbine and hence generate electricity. How is electricity produced in hydropower station? In hydropower station, The water collected in a dam is made to flow down with high speed to rotate the turbine, and hence electricity is produced. How is electricity produced? Nuclear power plant. In nuclear power plant, it produced from nuclear reaction is used to heat the water and generate steam. This system is made to move in high speed to rotate the turbine and hence generate electricity. State Faraday laws of electromagnetic induction. Faraday law of electromagnetic induction is state as whenever magnetic flux linked with the coil changes, an EMF is induced in the coil. The induced EMF lasts as long as the change in magnetic flux contained in the coil. The magnitude of induced EMF is directly proportional to the rate of change of magnetic flux in the coil. Give reason. When a ceiling fan is connected to the circuit of the solar panel, the fan does not rotate. It's because the solar panel produces direct current, but mostly the fan runs with alternating current. When a magnetic compass is placed near a circuit in which electric current is flowing, its needle deflects. It's because the needle of magnetic compass is deflected by the magnetic field produced by the current flowing in the circuit. Electromagnet is used in electric bell. Electromagnet is used in electric bell to generate magnetic field. When the current is passed in the circuit, the magnetic field attracts the metal striker and causing it to hit the bell gong to produce sound. The number of primary winding and secondary winding of transformer are not same, are never made equal. It's because transformer is used to increase or decrease AC voltage, but if number of primary windings and secondary winding are equal, it doesn't increase or decrease AC voltage, and there is no meaning of using it. So the number of primary winding and secondary winding of transformer are made never equal, means they are not same. The core of the transformer is laminated to reduce the loss of energy in the form of heat due to eddy current. It is limited by the material shellac or varnish. Transformers are used in the mobile charger. Transformers are used in the mobile charger to decrease high input AC voltage to low output voltage suitable for charging mobiles safely. The use of alternating current would be limited if transformers were not invented. Exactly. The transformer increases or decreases AC voltage to run many electrical devices requiring higher or lower voltage. If transformer were not invented, we couldn't increase or decrease the AC voltage and couldn't run many appliances. So the use of alternating current would be limited if transformer were not invented. A hydropower plant is better than a thermal power plant. Obviously, it is because hydropower plant uses water to produce electricity, which is renewable and pollution free, the source of electricity. But the thermal power plant uses fossil fuel like coal, diesel, which are non-renewable sources and cause environmental pollution as well, and may lead to energy crisis in the future as well. Step of transfer are used in power station. Step of transformer are used in power station. Step transfer is used in power station to increase the voltage of alternating current so that it is transmitted to a longer distance. Step down transfer is used in street. Step down transfer is used in street to decrease the AC voltage from high AC voltage like 11,000 to 220 volt for domestic usage. The electric motor and generator are in opposite in action. Obviously, electric motor and generator, they are opposite in action because electric motor converts electrical energy into mechanical energy, whereas generator converts mechanical energy into electrical energy. DC cannot be altered by transformer. Yes, because DC doesn't produce changing magnetic field in the primary coil, so that no current is induced in secondary coil of the transformer. Electricity and magnetism are interrelated. Obviously, electricity and magnetism are interrelated because electricity can be produced from magnetism by the process of electromagnetic induction, and magnetism can be produced from electricity by the magnetic effect of current. A soft iron core is used in the transformer. A soft iron core is used in the transformer as it easily converts mechanical energy into electrical energy so that current is easily induced in the secondary coil of the transformer. Differentiate between electric motor and generator. It converts energy into mechanical energy. It converts mechanical energy into electrical energy. It is based on motor effect. It is based on law of electromagnetic induction. Motor and dynamo. It converts energy into mechanical energy. It converts mechanical energy into electrical energy. It is based on motor effect. It is based on law of electromagnetic induction. Step up transformer, step down transformer. It increases voltage of alternating current. It decreases voltage of current. No number of turns of coil is secondary coil is more than primary coil in it. Number of turns of secondary coil is less than primary coil in it. AC and DC, alternating current, direct current. Its polarity changes periodically with time. Polarity doesn't change. It has certain frequency. It has no frequency. Dynamic generator. It produces current in small amount, large amount. It's used as bicycle dynamo. It is used as bicycle dynamo to light up bulbs. It is used in power station to generate large scale electricity. Generator and transformer. It's a device which converts mechanical into electricity. It's a device which increases or decreases AC voltage. It's based on law of electromagnetic induction. It's based on law of mutual induction. AC generator and DC generator. It produces AC, it produces DC. Generally, it produces high voltage current. It produces low voltage current. Draw magnetic field develop around a straight conductor carrying current in upward direction. Magnetic field is circular. Draw magnetic field develop around a straight conductor carrying current in downward direction. Now, when current is downward direction, magnetic field is clockwise, circular. Draw magnetic field around a solenoid. Current is going this way, then the magnetic field produced this way. If current is going this way, then here will be north pole, here will be south pole. Simple electric motor constructed by using coil, paper clips, dry cell, and permanent is shown in the diagram. Explain its working process based on the motor effect. Electric motor consists of coil placed between two opposite poles of magnet. When current is passed in the coil, magnetic field is developed around it due to interaction between the magnetic field developed in the coil and magnetic field of the permanent magnet. The coil starts to rotate, which rotates the other object attached to it. What are the uses of solenoid? It's used to make inductor. It is used to make the electromagnet. A bulb is connected to dynamo attached to the wire of the bicycle is not found to be glowing with steady brightness. It was found that bulb was bright, dimmed, and also turned off when the bicycle came to rest. Mention the reason for such observation based on the working principle of dynamo. When bicycle run fast, magnet is inside fast, and there is more change in magnetic link with the coil, and so more current is produced and bulb glows brighter, and vice versa. Write the types of transformer P and Q. Also write one use of it. P is step up transformer. P is step up from power station. It is transmitted to longer distance. So P transformer is step up transformer and Q is step down, because from high voltage it is used to convert that low voltage AC for domestic use. Transformer Q is used to decrease AC voltage from high AC voltage to 2020 for domestic use. And now numerical problem. Charger with primary coil of this is connected to input power of 220 volt to charger left of this. Find the number of secondary coil. We get number of primary coil is 550 here given. Secondary coil, what? Primary voltage BP 220, secondary voltage BS 20. We use the formula and submitting the values of these quantities, we get NS is 55 tons. Number of tons of secondary winding of the number of secondary winding of the coil of transformer used in a microwave is 10 times that of primary winding in the coil. If it is connected to the source of this, what is secondary voltage? So secondary winding is 10 times of primary winding. So let primary winding x, secondary winding will be 10x. Primary voltage is secondary voltage. Secondary voltage Bs by Bp equal to Ns by Np. Xx cancel. Here Xx cancel. So this into this we get 2200 volt. The ratio of number of the primary winding to the number of secondary winding of transformer is this. That is Np by Ns is this 22 by 1. And the primary voltage is this. Calculate output voltage means secondary voltage. So we use the formula Bs by Bp, or we can take reciprocal Bp by Bs equal to Np by Ns. So Np by Ns is 22 by 1. It's given in the question. So Bp is 220, Bs we can put, and we get the value of Bs is obviously 10 volt. What are the different ways of increasing magnitude of current produced by dynamo or generator? The different ways of increasing current produced by dynamo or generator are as follows: by increasing number of turns of the coil, by increasing strength of magnetic used, by decreasing the distance between coil and the magnet, by increasing speed of rotation of the magnet. What happens to the galvanometer when the magnet is put in stationary inside the solenoid, and why? When a magnet is put in stationary inside solenoid, galvanometer doesn't show any deflection, and there is no change in magnetic flux link with the coil, and no current is induced. What happens to a galvanometer when magnet is suddenly inserted into a when a magnet is suddenly inserted into a solenoid? There is a large deflection in the galvanometer as there is more change in magnetic flux link with the coil. Study diagram and calculate the number of turns in the primary coil of transformer. This type of question also may be asked. Is current is going into input side, primary, secondary. So Bp 220 volt, Bs 11 volt. Number of turns in this primary coil we have to find. Number of turns secondary coil is 50 turns, and we apply the formula Bs by Bp equal to Ns by Np, and we get the answer. This Np cross multiply, this goes this side, 11 comes down to 20 goes this side, 1000 tons. It comes the answer. Section D. Long question is carrying 4 marks. How can the magnetic field produced around a current carrying conductor be demonstrated by using iron dust cardboard conductor wire? Explained to the suitable diagram. This iron dust placed on a cardboard, and from the middle, if there is a conductor which carrying the current, then magnet is produced in circular direction. So iron dust are aligned in circular pattern as seen in the figure. To show the magnetic field generated around a straight current carrying conductor using iron dust, carbon, and conducting cardboard. BOARD cardboard and a conducting. We can follow the following steps. First of all, take the cardboard and pass a straight conductor through its center as shown in the figure. Spread iron dust on the piece of cardboard. When switch is on and cardboard is gently tapped means hit. Iron dust settle in a circular pattern due to production of circular magnetic field by the current resistor conductor. Study the pictures given below. Write what happens in the following situation. If magnet is slowly inserted into the solenoid, there is less deflection in the galvanometer. It's the electromagnetic induction. There is relative motion between magnet and the solenoid coil, so that less current is produced. There is less deflection in the galvanometer due to less production of current. While in introducing bar magnet rapidly into there will be more deflection in the galvanometer. This needle will deflect. Holding the bar magnet station inside the wire, there is no deflection in the galvanometer as there is no current to be produced. On pulling the bar magnet quickly out of the solenoid, there will be more deflection in the galvanometer but in opposite direction. Draw a block diagram for step up transformer, step down transformer, and write two uses of it. Step down transformer, step up transformer. Iron core, primary, secondary. Coils. It's used in industry. Use of step up transformer. It is used in industry for increasing AC voltage to run high power equipment. Power plant to increase AC voltage for transferring it to a longer distance. Use of step down transformer. It's used in TV to decrease AC voltage. It's used in mobile charger to decrease AC voltage. Explain the structure and working of transformer with a diagram. Structure of a transformer. A transformer consists of two separate coils, primary, secondary, wound on a laminate iron core. The coil of transformer in which AC voltage is given input is called primary coil, and the coil from which AC voltage is taken out output is called secondary coil. Thin insulated metal sheets are piled up to make the core of transformer. These iron sheets are coated with insulating material like varnish or shellac. This process is called lamination. The core of transformer is laminated to minimize the loss of energy in the form of heat due to the production of eddy current. Secondary, primary. Working of transformer. Transformer works on the principle of mutual induction. When an alternating current is passed through the primary coil, it creates a change in magnetic field around the coil. This change in magnetic field then induces the voltage in the secondary coil. This is how a transformer works. Explain structure and working bicycle dynamo with the diagram. Structure or bicycle dynamo. This is the bicycle dynamo. It is attached to the wheel. When wheel rotate, this also rotate. Then magnet also rotate. When magnet rotate, electricity is produced in the coil. Bicycle dynamo consists of a permanent magnet and a coil of insulated wire wound on a laminated soft iron. The coil is kept in magnetic field of the magnet. The magnet is connected with the cap of dynamo with an axle. This is the axle. Working of dynamo. When the wheel bicycle rotates, the cap of the dynamo attached to the wheel also rotates. That helps to rotate the magnet. This cap of dynamo rotates when wheel rotates. Then magnet also rotates. This causes change in magnetic flux linked with the coil, which induces current in the coil according to law of electromagnetic induction. Describe the structure and working of AC generator. Construction of AC generator. There are four main parts in AC generator fixed, namely field magnet. These two are field magnet. Armature. This is the armature coil. Slip ring and brushes. Slip rings, brushes. Working of AC generator. When in mechanical energy Using mechanical energy, the coil is rotated in a magnetic field. Then the magnetic flux link with the coil changes and the alternating current is induced in the coil according to law of electromagnetic induction. This induced current is AC as its mentioned direction changes in each rotation of the coil. History diagram answers the following. Name the type of transformer. It is step down transformer because name the type of transformer. It is step up transformer because number of secondary coil is more. That's why it is step not down. It is step up transformer. Step up transformer. Label parts A B C D. A is core, B is primary coil, C is secondary coil, D is input voltage. Write one use of this type of transformer. This type of transformer is step up, so it is used to increase AC voltage. In this principle, it works on principle of mutual induction. History diagram answer the following question. What type of transformer is it? It is it's also step up transformer is number of turns in secondary. The arrow should be in this direction. Here is little error, so let's correct it. Arrow should be in this direction. Primary coil is less than secondary coils, that's why it is step up transformer. Why is its core laminated? Its core is laminated to reduce the energy loss of energy in the form of heat due to eddy current. Calculate output voltage. We can easily find output voltage as previously done. Two figures solenoid given in the diagram. So which figure has north pole at the end X? Figure B has north pole at the end X. Figure B. How can polarity of solenoid be changed? Polarity of solenoid can be changed by changing the direction of current from clockwise to anti-clockwise. Name the factor that affect polarity in the solenoid. Direction of current in the solenoid affect the polarity in the solenoid. Okay, with this is the end of this lessons. Thank you for watching. Please take lots of advantage from all these question answers. Prepare well for your SCA examination. Best of lucks. Don't forget to subscribe this channel, share this channel to all the students of SCA. Thank you very much. I'll come up with some other important material of SCA of science next time. Thank you very much.